The next graph traversal on the list is DFS, that stands for depth first traversal or depth first search basically. And in this we are going to begin with the route as usual, but explore as far as possible. Means from the route we will go to some another node which it is connected to which the route is connected to, and from that node we will go to another node. We won't be exploring all the neighbors at the same point of time. We won't be exploring all the neighbors of a particular node at the same point of time. Rather, we'll be going on exploring one node at a time, and we'll be going inside in a form of depth. And once you are done, once you have reached as far as possible, you are supposed to backtrack and start with the next node which is unexplored and go in the depth for the same. So this can be better understood with an example. So let's go over here. We have taken the same graph which we took last time for DFS, and our route is going to be G. So the very first step is to take the route. So take route, which is nothing but G, and add G to the print list, print G. Once you print G, explore the neighbors of G. Take neighbors of G. Which are the neighbors of G basically? We have A, D and F as the neighbors of G. So we'll just mention out over here A, D and F are neighbors of G. But what depth first says is basically that don't explore all the nodes at the same, all neighbors at the same point of time. Explore a particular node as far as possible. So we are supposed to just take one node, and we have written A first over here. So we'll take A and we'll add over here, we'll add A over here, and then we will also print it. Once you have added A, you have printed it. Now consider A. So take node A, find the neighbors of A. So let's see, we are over here right now. Find the neighbors of A. The neighbors of A are basically G, B and D. G, B and D. So basically G is already visited, so we don't require this. So rest of the remaining ones are B and D. We'll consider B this time. So we'll add B and we'll visit B. Once we visit B, we are going to take B into consideration. So take node B, find the neighbors of B. So we are here. What are the neighbors of B basically? Neighbors of B are basically, there was A and there is E. A is already visited as we know, so we don't have to consider A. So now we have only one option, that is E, so we have to consider only E. So we'll put E right here and we'll add it to the printed list. Now once B is done, we have to take the next node, and the next node over here which we have taken is E. So we will be taking E. Find the neighbors of E. Over here we are. So what are the neighbors of E? It's B and F. So I'll write over here B and F. B is visited, so we don't require. We have only option, that is F. So we'll just mention out over here F and we will print it to the list. So now E is done. So the next node to consider is F. So we'll take F. We'll visit the nodes, we'll find the neighbors of F basically. It's G, E and C. So right over here G, E and C. So G already visited, not required. E already visited, not required. So we have to consider C. So take C and print it to the list. Now once F is done, we have to move to the next node, that is nothing but C. So we are going to take C. Now we are right here. Do we have anything to explore for C? What are the neighbors of C? Basically F is the neighbor, so we'll mention out F over here. But F is already explored, so we don't require it. So our list will remain to be the same. We don't have any neighbors for C. So we are done. We have no neighbors to be explored from C. After that, we are supposed to backtrack, as mentioned out here, that once done, as explored node as far as possible, we reached as far as possible, beyond which we are not finding any other more neighbor to be explored basically. So we need to backtrack. After that we need to backtrack. So let's start backtracking. So once backtracking from C means coming back to F. So let's get back to F again. Take F. What are the neighbors of F? Neighbors of F are C, E and G. All are explored, so the list will remain as it is. After that, we are supposed to move to the next one, and that next one is basically, so there is nothing to be explored at F2, so we need to now backtrack from F also. So backtracking from F means coming to E. So again on the new paper I'll start. So we are supposed to basically backtrack from F. So F is right here. Backtracking from F means considering E. So take E. What are the neighbors of E basically? The neighbors of E over here are F and B. So write F and B. If you notice, F and B both are visited, so we don't require them. So our list will remain to be as it is. G, A, B, E, F, C. It will remain to be as it is. So now E is also done. Now again backtrack to B. So we are going to consider, take B. What are the neighbors to B? The neighbors to B are E and A. So let's write E and A. Both are explored. So the list will again remain as it is. Now backtracking from B means backtracking to A. So let's backtrack to A. Take A. What are the neighbors of A? The neighbors of A are G, D and B. Now among this, G is already visited, so not required. B is already visited, not required. D, is D visited? No, so we need to add it to the list. So let's consider D. And add it to the list. So now the next node, we have already backtracked and reached over here, but now we need to consider the next node, that is nothing but D. So take D. What are the neighbors of D? It's basically G, A. Both are explored, so the list will remain to be the same. Anything else remaining to be explored, remaining to be searched? All the nodes have been explored completely, all the nodes have been visited. So this will be our final list. That's it for DFS.